Another thing let's go ahead and go through this one. So we have cosine of 2x. We're supposed to come up with sine of 2x. So here's where people kind of run into troubles here. So they start looking at their formulas. And they're like, okay, I know sine of 2x. So maybe I'll look here to get me cosine of 2x. But is cosine 2x on this side? Is there a cosine 2x on this side? Not a trick question. Is there something that says cosine 2x on the right side? No, there isn't. So this isn't going to help you get to cosine 2x, knowing sine of 2x. Whenever you're just trying to go from sine of something to cosine of the same thing, you're always going to use sine squared plus cosine squared equals 1. That would even be, in the case maybe I have cosine of smiley face, given that sine of smiley face equals 3 over 5. That's the same situation. The same thing is in our parentheses. Whenever you need to go from sine of the same kind of angle that's in here to cosine of the exact same thing that's in here, no matter what's in there. 6,000x could be in here as long as there's 6,000x here. You're always going to use sine squared plus cosine squared equals 1. So in this case, we know that sine 2x, so that's what I said. Well, if I ever have sine of something, we're going to say it's 2x. It's going to equal the square root of 1 minus cosine squared of that same exact thing. Like I said, these could be just smiley faces. Well, on the flip side, we can do the same thing with cosine. We can say cosine of 2x equals the square root of 1 minus sine squared 2x. That all comes from sine squared plus cosine squared equals 1. Well, in this case, I know that sine of 2x equals 3 over 5, so I'm going to use this one. So we don't need this one. We're just going to use the bottom one, because then we can plug it in and say, well, that equals 1 minus, and we'll have 3 over 5 squared, which is going to equal the square root of 25 over 25 minus 9 over 25, which is going to equal the square root of 25 minus 9 is 16 over 25, which equals 4 over 5. Now, I didn't give you a specific quadrant. And since we are taking the square root of everything, we have to stick with the fact that it's either plus or minus, so it's plus or minus 4 over 5, which is A. So anytime we are going from sine of anything to cosine of that exact same thing, we're just going to use sine squared plus cosine squared equals 1. The only time we're using the double angles is, say I have sine of 2x, and I need to get down to, maybe I change this problem to, you need to find cosine of x. Now you have to do something different, because these aren't the same number. If my x is 20, this would be 40, and this would be 20. So now you start having to use your double and half angle identities. The only time you have to use them if you're trying to get from 2x down to just x, or 2 alpha down to just alpha. Or if you look here, I have to get from alpha over 2 to just plain alpha. That's when I have to use those identities. All right? You got to just recognize, looking at those identities, what will help you in any specific situation. Because a lot of this unit is just problem solving. All right, it is you looking at identities and asking yourself which ones will work in this particular situation. All right, that being said, I didn't check your homework. A, because I was handing out tests. B, because I just assumed there's going to be lots of questions. Because, in fact, today is going to be almost like a practice day. Monday is going to be pretty much a practice day. These just take practice so you can get good at them. So that being said, what questions do we have? Brody?
55.
55. I have my sheet up here. I don't even have my sheet up here. That's okay. Let's see if I can find it. All right, 55 was that cosine 3t equals cosine cubed t minus 3 sine squared t cosine t. Is that right? Yeah. All right. So what I'm looking at is this cosine 3t. I have no triple angle identity. There is no triple angle identity that says cosine of 3t equals something, 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 something. So we have to put it in terms that we can break it down into 2t. 2t is the highest we can deal with. So what I'm going to do is I'm going to go back to, like on the test, where I had cosine of 2a. I changed it to cosine of a plus a. So in this case, I'm going to change this to cosine of 2t plus t. Because I have an angle addition identity that says this, if this is my alpha and this is my beta, I can rewrite this as cosine alpha times cosine beta minus cosine alpha. All right, sine alpha, sine beta, right? You agree? Okay. All right, so we're just going to rewrite this as cosine of my first angle, which is 2t, times cosine of my second angle, which is t, minus sine of 2t times sine of t. These two guys that I'm highlighting are now double identities, double angle identities. So if you go back to your identity sheet, did I replace it? I think I did. Oh, no, I didn't. Cool. Sine of 2x equals 2 times sine x times cosine x. So that is the only thing I can replace that sine of 2t with. All right, so I have to do that. Cosine of 2t can we replace with any one of these three. So in these cases, we have to look at the right-hand side. Let me just do this. My right-hand side has a cosine cubed t minus 3 sine squared t cosine t. So let's just do some trial and error. All right? So let's just start from the bottom. Let's replace cosine 2t with 1 minus 2 sine squared t and see what happens. So I'm going to replace this with 1 minus 2 sine squared t. And we still have that cosine t out front. So this is what I'm thinking in my head. I might not even write this down. What I'm thinking in my head is I need to distribute this cosine t to everything. So I have to distribute it here, and I have to distribute it here. Well, if I distribute it here, I just have a plain old cosine x. Do we have just a cosine x all by itself over here, or cosine t? No. So this one isn't going to work. So let's try the next one. So that isn't going to work. Let's try the next one. The next one is 2 cosine squared t minus 1. Now when I distribute this cosine, that will work, but this will be a negative cosine t. I look at the right-hand side and I ask myself, do I have just a negative cosine t? I don't have one, so that one's not going to work. So that leaves us with one option left, and that is to change this to cosine squared t minus sine squared t. And now I'm going to ask myself, okay, if I multiply cosine t by cosine squared t, I'm going to have cosine cubed t. Hey, I have a cosine cubed t. Awesome. Then I multiply a negative sine squared times cosine. That'll give me a negative sine squared cosine t. I have 3 of those. I have this negative sine squared cosine t. So this must be the route I'm going to go. And then we try the whole problem. If it turns out it's wrong, then maybe I go back and change that one. But now let's continue on. So I said we need to rewrite that sine of 2t. There's only one way to do it. And that is sine of 2 times an angle equals 2 times the angle, cosine angle. So we're just going to change that to 2 cosine an angle, sine an angle. And we're multiplying that whole thing by that sine of t that was on the outside. All right, now we just simplify. I distribute that cosine t. That will give me cosine cubed t minus sine squared t cosine t minus, I multiply that sine t times that sine t, and I'm left with 2 sine squared t cosine t. Put my parentheses in all of them. And we're done. I have 1 sine squared cosine, and I have 2 of them here. Add them together, you have 3 of them. So that just reduces down to cosine cubed t minus 3 sine squared t cosine t. Questions on that one? Do all those stuff make sense, Brody?
Yeah.
Okay. Other questions? Yeah. 63. Let's see if I can find 63 on here. Oh, 61, so close. All right, 63 is tangent squared. X over 2 equals secant x plus cosine x minus 2 over secant x minus cosine x. Well, there's not a ton I can do on the right side, but what I am going to notice, secant is just reciprocal of cosine. This secant is reciprocal of cosine too, so there really is just a whole bunch of cosines here. So I'm going to remember that when I look at that tangent squared x over 2, and I go to my half angle identity sheet. Because I can rewrite that. And I can rewrite tangent of x over 2 as one of these 3 different ways. All right? But I'm going to look at the right-hand side and say there's a bunch of secants. And there's a bunch of cosines. So perchance, I should maybe pick this one, because it just has cosines in it. It wouldn't make sense to turn it into sines, because in that case, we would have to find out how I get from sine to cosine. So we're going to pick that one. That's how we're going to start off at. So we're going to rewrite that as that square root of, and we said we're picking that one. So we have 1 minus cosine of x over 1 plus cosine of x. And that is squared. Well, when I square that, I'm just left with 1 minus cosine x over 1 plus cosine x. Well, here's the thing. I really can't do much more with this. It's pretty much as simplified as I can go. So it's a good sign that maybe I should look at the right-hand side. And the right-hand side, there isn't too much I can do except I could change these secants into cosines. All right, so like I said, on a test, something like that, if you're not sure what to do something. Do something correct. You'll get more points on doing something correct than making up stuff and then somehow forcing it to be right. All right, so if I'm not sure what I'm doing, I'm just going to change my secants to cosines. So we'll change that to 1 over cosine x plus cosine x minus 2 all over 1 over cosine x minus cosine x. I still don't know much to do. But I do know I don't like fractions over fractions. All right, so say I had like 1/2, and this is 1/2. I'd multiply the top by 2 and the bottom by 2, just to get rid of those fractions. So that's always a good step. If you have fractions over fractions, try to eliminate them. And we're going to do that by multiplying the top by cosine x and the bottom. And remember, we are distributing it to everything in the numerator and the denominator. So when I distribute this all the way across, we are going to have that equals cosine x over cosine x is just 1 plus, and we'll have, I'm going to write this in a slightly different order because I know what's happening, but I'm going to change this to minus 2 cosine x, and then I'll plus cosine squared x. And that's all over, well, cosine divided by cosine is 1 minus cosine squared x. Well, I wrote in this order because we have x squared minus 2x plus this 1. This must be something I can write as a binomial times a binomial. So that's what we're going to do in our next step. Well, in our binomial times a binomial, I'm just going to have a 1 out front because I have a 1 here. 1 times 1 equals 1. For this to work, we must have a cosine squared and a cosine squared. A cosine x and a cosine x. Well, they have to be both negative, so that when I distribute this, I'll have a negative 2 cosine x. Well, our denominator is a difference of squares. That is 1 squared minus cosine x. So this is really just 1 minus cosine x times 1 plus cosine x. Well, hey, those cancel out, and I'm left with that, what I had over here. So the only new stuff we did was this. Everything else, realistically, what we do is one big move. And then everything else is little algebra and identity twists, like changing secants to cosines and eliminating fractions. And then understanding how to take a trinomial and write it as 2 binomials multiply together, and realizing that we have a difference of squares. All right, other questions? Jack. 47. 47. All right, 47 starts out with sine 2 alpha equals 5 over 13. I said in those problems you have to know cosine 2 alpha. It is the key to getting sine alpha and cosine alpha. So anytime you see sine 2 alpha equals 5 over 13, you have to think to yourself, I need to get cosine 2 alpha. So my first step is to get cosine 2 alpha. Well, if I have sine 2 alpha and I'm getting cosine 2 alpha, I use sine squared plus cosine squared equals 1, which leads me to cosine 2 alpha equals sine squared 2 alpha. In this case, 5 squared is 25. 13 squared is 169. Well, 1 minus 25 over 169 is going to reduce down to 12 over 13 if you do it correctly. Then we recognize that cosine 2 alpha equals 2 cosine squared alpha. That's the whole reason why we find cosine 2 alpha first, is so I can now rewrite it as cosine alpha. I get rid of the 2. And so I just take that 12 over 13, replace it here. So now I have 12 over 13 equals this whole thing. Now you just add 1 to both sides, divide by 2, and take the square root, and you're going to come up with your cosine alpha equals 5 over square root of 26. You take that and plug that into your formula from the sine squared plus cosine squared equals 1. You plug it in here, and you should come out with sine equals that. Do all those steps make sense? Yeah. Okay. Brody.
Number 57.
Number 57. Here's a double angle one, so let's do that. Um, 57 won't be bad. This would be a good one to have on a test because it basically tells you what to do. So look on top and see that you have a cosine 2x and you have a cosine 2y. We can write those as any one of these top three.
Oh.
All right? And the right-hand side tells you how to write it. Look at my cosine 2x. Match it up with your right side. I need to eventually have 2 sine x. So I go to my double angle identities and I look for one that has 2 sine x in it. And it would be that one. Okay, so I'm going to replace that cosine 2x with 1 minus 2 sine squared x because eventually I want 2 sine x in there. Then I'm going to look at my cosine 2y. On the right-hand side, I need to end up with that being 2 times cosine y. So I look at my double angle identities and I say which one has 2 cosine y in it, and that would be the second one. And once you do that, I'll take a quick picture. Once you do that, you'll see that you have a positive one, a negative one. Those will cancel out. And you'll be left with negative 2 sine squared x plus 2 cosine squared x. You pull out a 2 out of the top. And now you have a difference of squares, and it will cancel out from there. Okay? Yeah. Other questions? Rena. Number 61 has 2 squared u over 2, so we have to use our half angle identities. We have to use our half angle identity. So what I did is I kind of worked on both sides. I said, let's first use our half angle identity and see how far it gets me. So our half angle identity is sine of x over 2 equals the square root of 1 minus cosine x over 2. But that needs to be squared, and there needs to be a 2 out front because there's a 2 here. All right, simplifying that, square root and square cancel each other out. I'm left with 2 times 1 minus cosine x over 2. Multiply by 2, and I'm left with 1 minus cosine x. I can't go much further than 1 minus cosine x, right? So that's when it tells me work on the other side. And since this is cosine x, and I have a sine squared in this numerator, I'm saying I don't want sine squared anymore. I want it to be in terms of cosine, because my left-hand side is cosine. So I rewrite that as 1 minus cosine squared. Notice it's a difference of squares. That's why I really pressured you on difference of squares. That cancels out, and you are done. Other questions? Sam?
How would you start 59?
How would I start 59? Well, so 59 is cosine 2x over sine squared x equals cosecant squared minus 2, correct? So we need to rewrite cosine 2x. And we have 3 possible ways. We have 3 possible ways to rewrite it. We can either rewrite it as cosine squared minus sine squared. We can write cosine 2x as 2 cosine squared x minus 1, or we can rewrite it as 1 minus 2 sine squared x. So what you would do is you look at the right-hand side. See how it's cosecant squared x? Well, cosecant to me screams that I'm looking at sine. Because 1 over sine is cosecant, right? So that means I'm going to change that cosine 2x to the only one that just has sine in it. So I'm going to change that cosine 2x to this. And then once you do that, you have to break it apart, and then you'll be done. It really is 3 steps. Changing that cosine 2x, breaking apart the fraction, and then you'll have your answer. Is that enough, or did you want to see it? Because you just asked how to start it.
I think that should be good.
Okay. Other questions? Okay. Then let's do today's lesson. Today's lesson isn't really new. It's just a little bit different, and most of it's just kind of practice. And then on Monday, there will be nothing new. It's just going to be more practice problems, because the more you do these, the easier they become. All right, so this one says find sine alpha over 2, given that sine alpha equals 3 over 5, and alpha is between pi over 2 and pi. So first of all, if I'm talking about alpha, I need to be in quadrant, well, pi over 2 is 90 degrees to 180, so that is quadrant 3. All right, it says find sine alpha over 2. So it's probably a good idea to write sine alpha over 2 in terms of just sine alpha to see what you need to do. So sine alpha over 2, using our half angle identity, do I have that on one of these slides? Probably way back here, huh? Sine alpha over 2 is going to be this bolded one. That is that plus or minus square root of 1 minus cosine x over 2. So we're just going to rewrite this as plus or minus the square root of 1 minus cosine alpha over 2. Do I know what sine alpha over 2 equals? No? Do I know what cosine alpha equals? Not yet. Because we know what sine alpha equals. So I don't know what this is yet, but I can find this value. I can find this value because if I know sine, I can easily get cosine. So this tells me to do this. Well, cosine alpha equals plus or minus the square root of 1 minus sine squared alpha. So it tells me exactly what to do. You don't know this. Find it. Because we know sine alpha is 3 over 5. So we're just going to plug that in. We'll have plus or minus the square root of 1 minus 3 over 5 squared. Working our way down, we'll have plus or minus the square root. I'm going to change that 1 to 25 over 25 minus 9 over 25. And that's going to equal plus or minus the square root of 25 minus 9 is 16 over 25. So we will know that cosine alpha equals, well, that's 4 over 5. No, we're not in quadrant 3. Who said quadrant 3? What quadrant are we in? If I'm pi over 2 to pi. 2. I don't know who wrote that 3. Guy's an idiot. All right. We should be in quadrant 2. Is cosine positive or negative in quadrant 2? Anybody? Bueller? Yeah.
It's negative.
It'd be negative. So this should be negative because we're in quadrant 2. Hey, now we know cosine. I just need to plug that in, and we have our answer. I just need to plug that in, and we will now know what sine alpha over 2 equals. So plug in your cosine. So we have plus or minus 1 minus. Instead of cosine alpha, I can replace that with negative 4 over 5 over 2. We could do that all. I think it's smarter to get rid of fractions whenever you can. So I'm going to multiply the top and bottom by 5. You do not have to do that. You can simplify it normally. I like to get rid of fractions right away. It saves me a lot of time. So that's going to equal plus or minus the square root of 5. I need a bigger square root. We'll have 5 minus a negative, so that's actually a positive, 4 over 10. Well, that's going to equal plus or minus the square root of 9 over 10. So that means our sine alpha over 2 is just going to equal 9 square root of 10 over 10. Yeah, did I make a mistake? 3, yeah, 3. That's what happens when I try to do too much in one go. 3 square root of 10 over 10. Now I have to decide if there's a positive or a negative in front of it. Here's where it gets a little dicey. Alpha is in quadrant 2. We are dividing alpha by 2. So picture my alpha being 100 degrees. 100 degrees is in quadrant 2. But half of that's 50. 50 is in quadrant 1. So what you need to do to figure out where alpha over 2 is actually divide all of this by 2. You have to divide all of that by 2. So this just gets you alpha. To get your alpha over 2, you need to divide everything by 2. So you will have pi over 2 divided by 2 is less than alpha over 2 is less than pi over 2. Well, pi over 2 divided by 2 is actually pi over 4. So our alpha divided by 2 is pi over 4 to pi over 2, which must be quadrant 1. So that is quadrant 1. So that means we are going to have a positive because we are in quadrant 1. Hopefully I did most of that correct. Yes, Liv.
So instead of doing the whole divided by 2 thing, could you do what you said before, like just think of A as a degree angle in the quadrant and then just divide that by 2 and then find the quadrant that's in? Or is that...
It works for quadrant 2 because 179 divided by 2 would put it back into quadrant 1, right? But say you're in quadrant 4. Depending where you are in quadrant 4, dividing by 2 can put you into quadrant 2 or 3, depending how big that angle is. So it'll work most of the time. Most of the time you'll be correct. And it's a good thing to do if you're just not sure what to do. Like just say, okay, pick an angle from there, divide it by 2, make a guess at it. This is a more exact way. But if you're on a test and that's all you can think of, write down that you did that and hope you're right. And if you're wrong, I'm at least, okay, she understands the concept of what we're doing. So that's what you get most of the points for, is understanding the concept of what we're doing. That's how I grade tests. Do you understand the concept of what we're doing? That's why some of you that didn't do well on your proofs actually got probably more points than you thought, because you made that. I'm looking forward, did you make a big step? Simplifying from there, you can get there. But did you make that big step? Did you realize that you needed to multiply by a conjugate? And then you messed up somewhere along the way. Because if you mess up once in identities, you can't prove it. All right, and I understand that. So I'm looking forward, do you understand the concept? That's what you get most of the points for in this, and what you got for the identities. All right, our next one says find sine alpha and cosine alpha, given that cosine alpha over 2 equals a negative 1/4. Well, if they give me cosine alpha over 2 equals negative 1/4, what I'm going to do in my head or on my sheet of paper is I'm going to write what cosine alpha over 2 equals using my identity. So we look at our identity sheet, and oh man, I got to go way back here again. Cosine x over 2 equals plus or minus the square root of 1 plus cosine over 2. Note, if you know one of these, you know both of them. Just one has a negative, one has a positive. All right, so we go back here. And we say, well, I can rewrite this as plus or minus the square root of 1 plus cosine alpha over 2. Now, what I did in the last one, I said, do I know this value? Do I know sine of alpha over 2? I do not. Do I know cosine alpha? I do not, so I had to find cosine alpha. In this case, if I run through that list, I'm going to ask myself, do I know cosine of alpha over 2? Yes, I do. Cosine of alpha over 2 equals negative 1/4. Now, stay with me here. The 1/4 does not go in place of that alpha over 2. It goes in place of the entire statement. Cosine pi over 2 equals negative 1/4. So negative 1/4 takes over that entire spot. Equals, and I really don't need that plus or minus because we're ending up squaring both sides, equals the square root of 1 plus cosine alpha over 2. Now it's just algebra. You need to get cosine alpha by itself. It's kind of like I have 1 plus x over 2, and I have to get that x by itself. First thing I'm doing is I'm going to get rid of the square root by squaring both sides. So we're going to square both sides. And I'm going to have, instead of a negative 1/4, I'm going to have a positive 1 over 16 equals 1 plus cosine alpha over 2. Multiply both sides by 2. That will give me 1 over 8 equals 1 plus cosine alpha. Then I need to subtract both sides by 1, which is really subtracting 8 over 8 on both sides. Subtracting 8 over 8, subtracting 8 over 8, and we're going to come up with a negative 7 over 8 equals cosine alpha. Here's what's awesome about a problem like this. I don't have plus or minus. I know for a fact this has to be negative 7 over 8 because I squared both sides. The only time you have to worry about plus or minus is if I take a square root, if something is under a square root, which we're going to in a second. Because now that I know cosine alpha, I need to find sine alpha. Well, that we've done a billion times. We're just going to use the fact that, once again, cosine squared alpha plus sine squared alpha equals 1. So we can say if I'm looking for sine, I can just rewrite that as sine, not even squared, just sine alpha equals plus or minus the square root of 1 minus cosine squared. Which will equal plus or minus the square root of 1 minus that negative 7 over 8 squared. I'm going to kind of jump down because we're kind of at the end of class. But you can simplify that on your own to get you that sine alpha equals, and you should come up with a square root of 15 over 8. Now you have to decide if it's positive or negative. In this case, we are dealing with sine alpha. Notice this is alpha over 2, so you need to multiply everything in this by 2 to give you pi is less than alpha, is less than 3 pi over 2. Remember, I just multiplied everything by 2. Multiply all that by 2, says your pi, alpha is somewhere between pi and 3 pi over 2, which is quadrant 3. Since we're in quadrant 3, this would be negative. And there's the bell, but we got through. All right, guys, work hard on these. The harder you work on these, the easier they become. If you're just using the answer key, as I always say, you're going to find it on the test. You're going to get like a less than a 50% on it. All right, guys, have a good day. Test corrections will be next week.